Okay, everyone. I'm Sri Prakash. Let's start the session. Question number first is related to the question 1, 2, 3. Here the given waveform of switching waveform, and given IL, the inductor current, and controlling IC is the controlling current. Related to this one given to the for boost converter, the peak current mode control implementation in a conventional boost converter. Given the average inductor current here, ILT is the IL when switch is on D and when switch is off, and I think 1 minus DIL. Here he asks some question related to this expression of Fm in the inductor average current and value of K1 and K2. Which one in this waveform, the NID, it's a duty cycle. It's given to obtain the duty cycle perturbation from the average inductor current. Here IL is equal to DIL and 1 minus DIL from this, and this waveform is given like that. This one IC, and this one triangular wave. So this slope is MC. Triangular is given here. This one IC given here, and ramp signal applied to the control signal is the reference signal, and IL is the inductor current. To compare this, after this given to the sub flip flop, and this one is switch on and switch off occurs for given the switching frequency here. This one current I think IC minus this one ramp signal. I ramp is the this one. If you subtract this one will find this signal is IC minus ramp signal IR. Okay. Here is given in the expression is the IL. IL is given as the average inductor current. Here given average inductor current when duty cycle on and duty cycle off. This one find from this expression. This one IL given. Where if I know about this, this one is the IL into dt, or this one is the IL into 1 minus dt, and apply it into both and find the average inductor current expression. For this, first of all, I want to draw expression to find the average inductor current. What is average inductor current? After that, I apply this expression. This one is the average inductor current in the waveform IL. IL I written in dt form is the this one is the peak current. Okay, this one I peak, and delta IL given. Can I say that this one inductor current is IL peak minus delta IL by 2. This one peak current minus of this current is the IL, this one. Then total is the delta IL. If you subtract minus delta IL by 2, I think this one, from the peak we find IL. And same thing applied here, but slope is different in both the condition. In the delta dt condition, the slope is m1t, and in on minus d condition, slope is minus m2. That's why for this one, I written like I peak minus this current, this slope into time is the total DIL. This one m1 into dt divided by 2. Subtracted, this one is fine, and apply to dt total for the averages of on time, this one current. After that, for off time, this one I written like this: I peak minus this slope, total slope divided by 2 is the this one. The total slope is m2 into 1 minus dt divided by 2. This one the average inductor current, and multiply by 1 minus d the duty cycle. I think dd is same, the same donation I use, dt 1 minus dt. This one for when switch is on, q is 1, this one for a q is 0. To exception given here, switch is q is equal to 1 and q is equal to 2, IL find from there and put the value of IL, this one. Okay. One second. I peak. What is I peak? I peak, can I return the I peak like IC is the controlling current, IC, this one minus ramp signal MCT, subtract this, then you find this time peak is the IC minus of MC into T. T is here the duty cycle, is the dt time. When at a dt time, this MC is equal to the IL peak, MC into dt. Here is the IL peak. Let's start expression. And I written as the average when IL peak minus m1 dt by 2 into dt and that time period of on plus IL peak minus m2 1 minus dt divided by 2 into 1 minus dt divided by total time period. The on time, off time divided by total time period is the average inductor current. Okay. IL peak written as the IC minus MC dt minus M1 dt divided by 2 into d plus tt cancel out from both IC minus MC dt minus of M2 1 minus dt divided by 2 is the IL average. Then apply, solve this, 1 minus d here. See here for the MCDT is the d multiplied by here IC minus MCDT into d. This one is a minus d, is the cancel out, d minus d, only 1 is remaining. I think IC minus MC dt only remaining, d term multiply here, minus d multiply by here, and they both are cancel out. After that this one here M1 d square t divided by 2, this one is a negative, minus M2 t divided by 2 into 1 minus d square. Solve this. To d square minus M2 t divided by 2 1 plus d square minus 2d. Sorry, I think t is missing here. This one t. Okay, t is here. Apply perturbation of the signal. I think inductor current perturbation, duty ratio. M1 is the slope in the boost converter. M1 is the Vs by L is the slope, and M2 is the Vs minus V0 by E2 is the slope. So this 2 is not there. M2 is the Vs minus V0. Then both are applied by perturbation. That's mean M1 and M2 also come in the perturbation. Duty ratio IC minus MC dt. If I apply IL plus IL cap, IC plus IC cap, MC into T, D perturbation, D plus D cap, minus M1 plus M1 cap into D plus D cap square, 2T divided by 2, minus M2 plus M2 cap divided by 2 into T in D, 1 plus D plus D cap square minus 2 D plus D cap. Apply whole the perturbation. After that IL plus IL cap, here IC cap, if you multiply here MCT D minus MCT into D cap. First of all open the bracket here, M1 cap, D plus D square means D square plus D cap square plus 2 D cap into T divided by 2 minus same thing here, m2 plus m2 cap into t divided by 2. Same apply here, d square plus d cap square plus 2 d cap minus 2 d minus 2 d cap. Okay, see here, this is the perturbation of d cap is the very small value, that's why taken is the 0. When two perturbation multiply in one less than 1 point, this will take a 0 because of the perturbation is very low. Okay, IL plus IL cap, IC cap minus MC TD minus MC TD cap minus this one multiply and find M1 D square into T divided by 2. After that M1 multiply by here, then find M1 D cap T, 2 cancel out, minus M1 cap D square T by 2. Then M1 cap, see here, M1 cap and D cap multiply both here. That it means two perturbation multiply one place and take a 0. That's why I not written I here. Only 3 terms are coming. Minus same thing apply here for the perturbation M2 1 D square 2D is the 1 minus D whole square. I think that's why I written here M2 T divided by 2 1 plus D square minus 2D and M2 multiply by D cap here, then find minus M2 D by 2 2D minus 2 into D cap M2 over M2 dash multiply same here minus M2 cap divided by 2 to 1 minus plus D square minus 2D and D cap multiplied by D cap is the 0. M2 okay. See here further sometime IL here, IL is equal to MC dt M1 T square and M2. Find here IL is equal to MC dt and MC, IC into MC dt and M1 D square and M2 1 minus D square is the same. The cancel out from IL, only IL perturbation is remaining here. And that's why IL cap is equal to IC cap minus MCT D cap. This one term of present M1 dt into D cap M1 cap D square T divided by 2 M2 T. If you take a common minus here, then you find 1 minus dt into D cap M2 cap T by 2, then you find 1 minus D square here. take a d cap as a common. IL cap is equal to IC minus M1 cap d square T by 2 minus M2 cap T divided by 2 1 minus d square, sorry, whole square, minus d cap take a comma, then find M1 dt minus of M2 1 minus dt, then find d cap where asking the question, then find d cap is equal to transfer from d cap to left side and IL to the right side, then find IEC minus IL cap minus M1 cap d square T minus of M2 cap T divided by 2 1 minus d square and divided by take amount 1, so take here I think someone, this one is the see MCT M1 dt M2 T 1 minus dt MCT plus M1 dt minus M2 T 1 minus t. Okay. Next thing is given here M1 and M2 are the boost converter is given in the questions. Then boost converter I try a circuit like this on BC. So now VL when switch is on, this one, and first condition, then inductor current will flow like a Vs L di by dt is equal to Vs. This means slope is dIL by dt is Vs by L. Same thing in the second condition. When switch is off, then we find this one can flow like that. L dIL by dt is equal to Vs minus V naught. Then dIL by dt Vs minus V naught divided by L. When you put in the average voltage, this one, dIL by dt into dt plus dIL by dt 1 minus dt Vs by L into dt plus Vs minus V naught divided by L into 1 minus dt. Average inductor voltage in the inductor voltage in inductor is the 0, is the volt second balance equation from volt second balance equation. That's mean you find Vs by L into dt plus Vs minus V naught divided by L into 1 minus d I think L multiply by here. Take so is equal to 0. Okay, come to the point here. Put M1T, M1, M2 is the value M1 is a given, like is a given in the slope question. See here, M1 is given as the inductor current slope when MOSFET is on. MOSFET is on, then you know about slope Vs is equal to L. I find it, and minus M2 is given. Minus M2 given slope when MOSFET is off. It means minus M2 is equal to Vs minus V naught given by L. It's not given M2 is equal to here, it's given a minus M2. That's why I take a M2 here, then put a minus M2 here is equal to Vs minus V naught in the equation where I find. Take this equation, 1 second. Put value is the M1 cap is equal to Vs cap by L, or you can also written as V in, and minus M2 cap is written as Vs cap minus V naught cap divided by L is the slope. Then we find D cap is equal to IC minus IL cap minus M1 is equal to Vs cap divided by L into D square T by 2 minus M2 cap. M2 is minus M2, minus minus cancelling is plus Vs minus V naught cap divided by L 1 minus D square divided by 2 and 1 MCT plus M1 is a Vs. In both conditions, take a 1 by L is a common. Vs into dt. M2 here minus M2 put here is the past plus Vs minus V naught into 1 minus dt. Yeah. From this equation, dt is defined is the this one is the 0 inductor voltage, average inductor voltage. That's mean we find divide by MCT. Take IC, IL cap. If you open this 1 minus d square, find 1 plus d square minus 2d, and 1 plus d square is the minus d square is the considered Vs term. Only Vs by 1 minus d term is present. Take a common Vs cap divided by 2L in the both condition. D square cancel out, only this term is present 1 minus 2d. I think one is positive. 1 minus 2d present here. plus V naught. V naught is minus take V naught cap divided by 2L into 1 minus D whole square T. Take a negative common here. IC cap minus IL cap, take minus common, Vs cap divided by Vs cap is equal to minus 0.5 plus D into T divided by L minus V naught cap common T 1 minus D square divided by 2L. This is the expression in the D cap. See in the question, what is expression of D cap? D cap is like that. Fm is common. After that, IC minus IL minus K1 minus K2. Okay, what is the common factor is the Fm in D cap, and K1 K2 is the voltage of input voltage and output voltage factor. Is asked about the Fm, K1 and K2. That's why you directly say that this one is the Fm and this one is the K1 and this one is value of the K2. Okay, this one is the in option, first one, this is the last one, I think this one is third one. Okay, question number first is finished. Okay, question number second. Okay, I think first, second and third in the question number first, and next one is question number 4. So, question number 4 is given the perturbation, small signal losses already given. Okay, but the buck converter, the LC circuit is given, is the particle buck converter, and is the also given a perturbation of all thing, and ask about the IF, this one current divided by D cap is the perturbation of duty ratio. Normally this is the transfer function like this, V output by D cap, but here ask about the IF, this one in this question. Then you find IF is coming from here. Okay, this one is the actual IL cap is given, and multiply by this one gain of low pass filter. After that you find IF, then you written like this, IF is equal to IL cap into G low pass filter. Okay, simple. You find IL cap divided by D cap. If you find this, then put the value of IF in term of IL, then you find the overall expression, and given is the option Z1 Z2. Then don't need to open the expansion, this only simple use of Z1 Z2 is the V naught. I not so is the for the output current is the V naught by R also, don't need to take this, and is given a V in is 0 is a perturbation. It means this one is short circuited. When this one short circuit, this one is the also short circuit here because of the this one shorted. Only this voltage source is present. Okay, and this one is a Z1, and take the Z2 in one form. After that, find the overall, and redraw the circuit like that. V in 0, that's mean the inductor present here. Inductor R is also given here for the Z1, and this voltage is work as the voltage source. V in D cap, and this one is Z2, Z1, sorry, this one is the Z2, simple circuit, apply this one IL cap into dt, I think you know that, apply voltage KVL, then find V in into D cap T is equal to IL cap T Z1 plus Z2, and IL by D cap, take IL divided by D cap, and find V in divided by Z1 Z2. So you know IF is equal to IL into gain of low pass filter, multiply by this here, then find IF cap divided by D cap, V in into gain of low pass filter divided by Z1 is Z2, the expression of that. I think this one is the answer, this third one. Okay. Question number 5 here. The output voltage of boost converter is to regulated at 3 volt by current mode control. The input voltage V in is 1 volt and 3 volt is the output voltage. Inductor value is 1.1 microhenry, switching frequency 500 kilohertz. The load resistance can vary between 10 ohm to 1 ohm. It means the load is vary. When resistance is decreased, then current increase. When designing the controller, a good selection of gain crossover frequency, omega GC. Omega GC is the most important thing in the designing of controller. This is defined as the bandwidth of the controller. What is your gain crossover frequency, and the gain is 1 by root 2 of total gain. This one is the bandwidth of any system. Then omega GC should be less than of that. The frequency is given 500 kilohertz. First of all is asking for the boost converter. If you simply use the buck converter, in buck converter is the in a transfer function, the 0 is not the right of half plane, but in boost converter and buck boost converter, the 0 is the right of half plane. S is negative in buck boost converter and buck boost converter. That means the omega GC should be in range that neglect the 0 effect of right of half plane. This one decrease the phase margin also. That's why you should choose as a range of gain crossover frequency to eliminate the effect of the 0 in right of half plane. In buck converter, this is not a right of half plane. 0 is the in the left of half plane. Okay, I also explain from the transfer function of the boost converter. I think this one I draw the transfer function of boost converter, buck converter and buck boost converter, but I almost again don't worry. So two switches C R, this one V naught I M. Okay, first of all I written as average inductor current, average inductor voltage and average capacitor current. After that take a perturbation, something apply here. First of all average inductor current, sorry, average inductor voltage. So this time here, when switch is on, then Vs in the VL voltage of inductor, switch is on, this one, into D, plus when switch is off, then we find Vs minus V naught into 1 minus D. That's mean V in minus 1 minus D V naught. Apply perturbation, DIL cap by dt. Then we find V in minus, here perturbation use D is D plus D cap and V naught is the V naught plus V naught cap. Same I written directly here. Question number first. Second one, the current, and switch is on, this one, then IC here, I naught here. IC is opposite of the I naught is the V naught by R. Something apply here. Then negative of I naught. And when switch is on, off, then this IL flow like that. IL minus naught by R, 1 minus D, IL 1 minus D minus V naught by R. Apply perturbation here, then we find from question number first and question number second, draw a circuit diagram. ILK, see this one, V in minus this one. If you find V in this one given here is the positive and this one is negative, then negative and positive, D cap V naught here and Vs IL here, this one inductor current. This equation satisfy for the voltage here. If you take a 1 minus D here, then we find V naught here and the transfer in the primary side, find V naught here, 1 minus D V naught, term ratio. And when the current is transferred in the secondary side, this will find 1 minus DIL here, then 1 minus DIL capacitor current, output current, and some extra inductor perturbation current. Then we draw here, find D cap into IL. For find transfer function, you know about the V naught by D cap. When Vs is taken, perturbation 0, it means Vs is constant, then this one is short circuit. Then I try another circuit, only inductor current present here. See here, inductor L when transferred into the secondary side, then find overall inductance and take a Laplace transform. 1 minus D square is the term ratio, and when voltage transfer here, then D cap V naught divided by 1 minus D, and this one D cap into IL is the same 1 by SC. The circuit. and apply KVL. Take a superposition. One time take a voltage source, second time take a current source, after that connect to the both and for the output voltage. This one is the output impedance, this one is input impedance. Apply like that. So find as if you take a voltage source, then this one is connected in series, and find from the current source, then this one is connected in the parallel. Then V net cap written as d cap V naught divided by 1 minus d is the voltage source. Then find the this one impedance 1 plus SCR, from that divided by total impedance, this one SL divided by 1 minus d square. See here, when the current is you take this one is the I naught and this one IC. I naught is the negative from here. When this current is flow like that, then it means this one negative d cap IL, and opposite of the impedance here SL divided by 1 minus d square divided by total impedance SL divided by 1 minus d whole square plus R divided by 1 plus SCR. This is the current. After that multiply by impedance with the voltage, then multiply by the output impedance, R is equal to 1 plus SCR. Okay, solve this. When you solve this, then you find V naught d cap common. IL actually IL is a V naught divided by 1 minus d IL is equal to I naught. Because of when switch is on, that time IL flow average, if we take average, then average capacitor current is 0. It means the total IL flowing to the output is the average current. Then we find 1 minus d times. When switch is off, then total IL flowing to the output. That's mine. IL is equal to V naught divided by R is output on 2 1 minus d. Take V naught 1 minus d is a common. Promote d cap also common. V naught divided by d cap, the transfer function, and V naught divided by 1 minus d common here, and this one is the denominator is the common. You have to find R 1 minus d square minus only SL find here, SL R cancel out. If you find V naught by R 1 minus d here, then R cancel out, and only SL find here divided by R 1 minus d whole square plus SL plus S square L C R. So take CR calculate here. Take L is common. V naught into L divided by 1 minus d is the transfer function. R 1 minus d square divided by L minus S divided by R 1 minus d square plus SL. This one is the 0 right of half plane. If you this one is positive, then then 0 is left of half plane, but here is a negative term. It means 0 of the system is the right of half plane, is the non-minimum phase system. He is reduce the phase margin. If you reduce the phase margin, then zeta value should increase. If zeta should decrease, then you find the overshoot also increases and phase margin decrease. Okay. Because of the phase margin is equal to 180 plus 5 total angle, but when negative term here, then this one more subtracted from the 180 degree. This means phase margin reduces. and phase margin distribution, so overshoot, peak overshoot also increased. To reduce this, then omega GC should be in range. You find the transfer function right. If you draw a Bode plot of this system, this one is the gain, then you find this again like that. This one is the pole, this one is the 0. We should use as a gain crossover. This one, if you use this one is the gain crossover frequency omega GC. If you take this one is the omega GC, then the 0 is inside the omega GC in the transfer function is a dominated factor. But if you want to control as the robust controller is used and the proper, then you should take this one is the in outside of the omega GC, means not a dominated factor. Then you should you like that. This one is the cos, this one is the 0 outside of the omega GC. And this is your omega GC. When omega GC is same, if you take a same as the shift frequency like that, or a secret frequency, approximate frequency, that means that 0 is come inside the system. And when they reduce the omega GC from system frequency, actually omega GC will take in like Fs divided by 10, I think 10 times less than 10 times or 5 times less than. That means the system should be in robust condition and the first. And when omega GC more reduced because of in the boost converter and buck boost converter, omega GC also more decreases because of the this 0 order. 0 is present in the right of half plane. To reduce the right of half plane 0 or eliminate a non-dominating factor like that, then you should decrease the omega GC in a range like a minimum omega is the right of the plane, so reduce 1/3 of this frequency also. The thumb rule like so, like that. Omega GC should be minimum part of omega of right of half plane. This one is right of half plane. Zeros because of this one is a negative term here. Half plane. If you by third time, 3 times. If you want to try in frequency, then multiply by 2 pi. Here divide by and switching frequency of 10 times or 5 times of switching frequency, which is the minimum of this, and minimum which is the base minimum. If this one is minimum, and take this, and which this one is minimum, then take this. You will find omega RHP. This one R 1 minus d square divided by L. Calculate this. Take R is equal to minimum value should be minimum, R also minimum. Then I think this one given 10 to 1 ohm, then take 1 ohm. L is 1.1 microhenry. This one 1 ohm, this one 1.1 microhenry. And DT ratio in boost converter, D is equal to V naught minus V in divided by V naught. I think this one is 0.67 or 2 by 3. Take this, then you find like that I think 99 k radian per second. You convert in the frequency and divide by 2 pi, then you find in frequency f RHP is equal to 15.76 kilohertz. After that you will divide by 3 also for take us some time to build the energy of inductor and supply to the output system. Then you take 1/3 of this, then you find should be minimum. What is minimum? Then you take this is minimum. This one is the 5.25 kilohertz, and 10 times is the 50 kilohertz here. This is the minimum value. Then take this one, should be less than FGC should be less than or equal to 5.25 kilohertz. It means question number this one, gain crossover frequency. Okay, everyone. This is the last question, I think, for this session. Only 5 questions here. And thank you, everyone. Okay, I just show you at okay, I send you a video link of this. Don't worry. Here is the transfer function of this. I already draw here. Everyone see, this is my screen visual. Okay. This is the transfer function when you used. I already draw transfer function like R1 minus D square minus SL divided by R1 minus D square plus SL plus S square SLR. Then put all the value. Take, I am taking a capacitor as the 10 microfarad. Here is the capacitor is not given. I take 1 by 10 microfarad. Then I find transfer function like that. Okay. For this I use a scissor tool system. If you draw this, run this, then you find run here. See here, when I am taking the transfer switching omega GC and 10 times decreases, then you find 50 kilohertz omega GC, and this one is the right half pole is outside of the 0. This is the omega GC here, out of the omega GC, and for This one is the system step response, the very deteriorate step response, not accurate step response. Then I reduce the omega gc like that. You see here what is the step response is coming. Reduce like a 15 kilohertz I read. Then see here the phase margin is 88.9 degree, and omega gc I think fgc frequency this is a 15.2 kilohertz if I take from the system. Then find the step response like the smooth step response like that. Okay. If omega gc is increases omega gc like that, if you increase the omega gc, then find the frequency increase, the phase margin decreases. Phase margin decreases, then overshoot, peak overshoot also increase. Here, peak overshoot increase. When you decrease the omega gc, then phase margin increase. When phase margin increase, then omega then peak overshoot decreases, and system is smooth from 1 to 2 cycles. That's why I'll take in 1 by third and omega gc for the boost converter. Okay, I stop here. 10 kilohertz, yeah, you can take 10 kilohertz also, but here I am taking only for the ideal converter. Not, I have not taken a resistance of inductor and resistance of the capacitor like that. That's why it's coming like, if you take a more everything, then so equation is different from this, but response is same as like that. No, is the standard is the 1 by third actually given in the standard rules. That's why I've taken 1 by third only. Don't take 10 kilohertz. For the boost converter and buck boost converter, if you take for buck converter, here there is not right half plane zero. There that time you can take 10 kilohertz also, or 50 kilohertz also. But for the boost converter, the right of half and zero is present. That's why you take 1 by third alpha. Of right half happen zero frequency. Okay. I put a link of the channel and I uploaded this video today or tomorrow.